Alright, so we look at 16. We look at the second row of the periodic table, starting with lithium. What happens as you go down towards neon? In general, what happens? It gets bigger or smaller? It gets smaller. Okay, this is because the nuclear pool, so MP, increases, all right, and the shielding electrons remains the same. The nuclear pool increases, the shielding electrons remains the same. So basically that nuclear pool gets stronger as you go down because of that. So with the size of chlorine, if we did not give you numbers, if we instead gave you something like 1.04 and then X and then 0.94, you would have to be able to figure out that it is between this one over here, which is sulfur, and this one over here, which is argon. You'd have to be able to determine what it is. So you need to know that it's bigger than argon, but smaller than sulfur. Now, which one's larger, helium or barium? Barium, because it is closer to which element? Francium. It's closer to Fr, francium. All right, let's talk about electronegativity. Anybody have the definition of electronegativity in front of them? Exactly. So with electronegativity, it's the ability to steal an electron away from another atom. The most electronegative element is going to be fluorine right here. Okay? Most of these guys over here have no electronegativity because it's group 18. We don't really consider them because they are already stable. Krypton and xenon kind of sort of have one, but don't really worry about that too much. That being said, over here you'll find your higher values. Okay? Over here you'll find your lower values. As you go down, you will get lower values. So for number 20, what ends up happening is as you move down the group, it gets smaller. It decreases as you move down a group. Okay? So the answer for number 20 should be decrease. And then for 21, as you move, oh, whoops. Yeah, never mind. All right, so how do those shielding electrons affect electronegativity? So for 21, as you move down a group, the number of electrons increases. How do those shielding electrons affect electronegativity? It decreases the nuclear pull, therefore weakening the electronegativity. If we look at the third row, starting with sodium, moving towards chlorine, what happens to the electronegativity atoms as you move across the period of chlorine? What ends up occurring there? To increase or decrease? If you move across the period, it increases as you go across. All right, so again, same thing for number 23. If we give you two values, you need to be able to figure out where it is in between. Okay? For 24, which one has the largest electronegativity, francium or fluorine? Fluorine, okay? All right, so let's look at ionization energy. So for ionization energy, what we're looking at here. Anybody remember what ionization energy is? Nope. All right, it's the energy needed to pull an electron away from an atom. Okay? So with electronegativity, when we talk about that, we're talking about how good of a thief it is. But with ionization energy, we're talking about how much is required to pull an electron away from an atom. So you think about it this way, with electronegativity, it's talking about how good of a thief this atom or element is. And with electronegativity or ionization energy, we're basically talking about if you need to lose some weight, it's easier if you're more overweight to lose the weight than it is if you're closer to your goal weight. All right, that's one way to think about it. Over here on this side, well, with the exception of that guy, but over here on this side of the periodic table, you generally have lower values than on this side of the periodic table. Why is that? Anybody want to take a guess? Sure. But what is it over here that we have? Non-metals, okay? So over here, it's going to be harder for them to pull an electron away from an atom versus over here where they're just willing to give it away. Okay, so with 26, 27, I'm going to answer those. 26, as you go across, what happens? Or sorry, as you go down, what happens? As you go down a group? So let's look at this. Let's try to blow that up. Okay, so as we go down, say group 2, right? Let's go down this group right here. What happens as you go down in general? It decreases. So as you go down, it decreases. And if you go across, it's going to do what? Over here we have 400. Over here we have 1100. So it increases as you go across. Okay? For 28, as you move across the period, the number of protons increases. How does this affect ionization energy? So the more protons So the more protons you have, the higher the nuclear pull, meaning it is harder to take an electron. Okay, so that's one of those things where it's just, you got to remember that. Okay, the more protons means higher nuclear pull, meaning it is harder to take an electron away. All right, so now what we're going to do is we're going to look at number 2 and 3 at the bottom. So the formulas that you're going to need to use. Anybody remember what the first one is? Starts with a C. C equals lambda V. And the other one is E equals HV. All right? C is a constant. H is a constant. C is 3.00 times 10 to the 8th meters per second. And H over here is 6.626 times 10 to the negative 34. And the units are joules seconds. It's a weird unit. It's okay. So right here, if a CD uses a wavelength of this number, what is the frequency? So again, lambda is wavelength. And that's not a 2 or something like that. That's actually called lambda. It's a Greek symbol. And V is frequency. So whenever we plug this in, we know what C is going to be, and we know what our lambda is going to be. We need to solve for V. So we do this 3.00 times 10 to the 8th meters per second equals 7.8 times 10 to the 9th. Where did I get that from? Put that in a scientific notation. Times V. So I'm going to divide both sides by 7.8 times 10 to the 9th. Now I'm going to warn you, you need to use second comma sign, which gives you an E on your calculator. If you don't do that, you're going to get the wrong answer. But if you don't know what I'm talking about with the second E button right here, what you will need to do is put both of these things in parentheses before you divide. Okay? Otherwise, you're going to get the wrong answer. So if you stick that into the calculator, you will end up getting one of two answers. You will either get 3.84 times 10 to the negative second, or it might come up as 0.0384. Either one works. Either answer works. So from question 2, what is the energy? Well, energy equals HV. So what I'm going to do is multiply 6.626 times 10 to the negative 34th, multiply that by 0.0384, and that will give me what my answer is. All right? Now the last part, down here at the bottom of this part, on the very last page, you have some empty space. I want you to go ahead and just write down what I'm about to tell you. I'm not going to tell you why it's important, but I just want you to pay attention. You need to know the ground state configuration. Okay, so that's 1s2, 2s2, 2p6, 3s2 of calcium. The shorthand configuration, oh my gosh, can't spell short, S-H-O-R-T. Okay, good. Shorthand of chlorine, and you need to know potassium. Not going to tell you why, just going to tell you that's important. Hopefully you understand subtlety and the need to keep secret. Okay? Just saying, those might be important for your test tomorrow. You also probably want to know neon, rubidium, and lithium. Okay, just saying. Those are important things to know. So good luck on your test. If you need anything, email us through Adline. My name is william.fortin@rasd.org. Or you can go to matthew.fields@rasd.org. If you email us through Adline, you need to make sure that you leave your actual return email address. Otherwise, we will not get back to you because that's just the way it goes. So if you have any questions, let us know. This should be up relatively soon, and the links will be on Adline. Thanks a lot.